Hello my dear students, how are you all? Welcome back to our YouTube channel Diksha Karnataka. I am Ankit Srivastav, continuing with your ongoing series which is 16 KCET Mathematics in 100 days. I hope all of you are doing very good, right? So we are into our calculus part, right? We are dealing with it. So we have had only 2 sessions on it. First session was based on the revision of the limits from PU1 and second session was on the continuity part, right? We did questions on that. We did the differentiation, when can we call a function continuous, okay, when can we not call a function continuous. So we are going to deal today with differentiability part, right? So in this we'll learn about what is the differentiability, like when can we call a function differentiable. Then we'll go ahead and solve questions on differentiability, and how will we do that? By learning the concepts or learning the formulas which are there for differentiation, right? And we'll also apply the general theorems with the differentiability. Means, like for example, if you have to check product rule is there, a quotient rule is there, chain rule is there. So how we apply these formulas, these general theorems to solve problems in our questions, right? So we will deal with all of this in today's session. So I hope you are all very excited. So take the pen and paper out, get energized, have some water, okay, and let's start with the session, right? So let's begin. What is coming up for the first time? Differentiability of a function at a point means for a given function y equal to f of x, okay, we are checking the differentiability whether the function is differentiable or not at a point x equals to c, at a point x equals to c. So when can I say that? Whenever we have this, okay, little correction, this should be f of c, this should be f of c. Whenever we can have this limit existing finitely, okay, then we can call the function fx is differentiable at point x equals to c, okay, and this is also called as first principle of derivative. First principle of derivative, which is ultimately used to solve all of your formulas that you know. For example, you know this formula, right? Differentiation of x power n is nothing but n times of x power n minus 1, right? This is the differentiation of a polynomial function in the order of x power n, right? So what we write it as n x power n minus 1. So all these, not even this, you have trigonometric function, whatever functions you have where you are applying the differentiation rules, okay, the separate formulas are given for all the functions. You use this first principle of derivative to find these formulas, okay? So that's why this becomes very important. But ultimately what we do is we stick to the formulas because that's more than enough, right? If you know the formulas, you can apply to the questions and understand. But if you want to know all the derivative also, so this concept can be used, this definition of differentiability can be used to reach the formula that you're getting, all right? So let's see now how we represent it. The representation looks like this, bacha. I'll read it for you so that you understand. This is read as the function's derivative at point c. The function's derivative at point c or differentiation at point c is given by limit fx minus fc upon x minus c when x tends to c. Okay, I'll repeat. The function derivative at point c is given by limit of the function fx minus f of c divided by x minus c when x tends to c. All right, let's move on. Okay, now these are other ways of writing as well. Okay, you can write it as f dash of c as it is, or you can write it as differentiation of f of c, or you can write it as d of f of x by dx. We will use this mostly. Okay, the first and third one we use the most. I'll show you. So this one is basically this I was saying. We use mostly this as y derivative, or we also use this as dy by dx. If you look closely, same things written here: y derivative, f dash of c, or dy by dx. All right. So both of them are at which point? At the point x equals to c. All right. Now coming up, we have right hand derivative. Right hand derivative means whenever at, let's say we are talking about the point x equals to c, right? X equals to c. So when I approach this point from the right side, okay, the limit should be this limit value. If you check here, that this limit value, this was the limit of the first principle. This is the definition of the derivative from the first principle, right? So f of x minus f of c upon x minus c. So this limit should exist from right hand side. So if you see as c plus exist, this should exist. Okay, this same thing can be rewritten as we used to do as we used to find the right hand limit. For the positive sign we used to do what? C plus h or a plus h. Same thing. At this point we have taken it as c plus b. Please check. So when b tends to 0, we have this, the limit transforms into f of c plus b minus f of c upon. How we are getting this b, bacha? This is simply c plus b minus c. What is the derivative? if you remember the first principle where it is x minus c. X minus c, what is x basically? X is replaced as c plus b, right? C plus b. So I can write x minus c as c plus b minus c. How much is that? Simply b. That's what is written here. That's what is written here. So this limit, when we are trying to find out our RHD, what is this called as? RHD, right hand derivative. We just write in this form. Either you can use this form or you can use this form. This is the end form that we use to solve the questions. So f of c plus b minus f of c upon b. Simply b. Don't have to write c plus b minus c. C plus b minus c. Don't have to write that. Okay. So I hope you understand this. Alright, sir. Yes, sir. We understand it, sir. Nothing is there. Right? Simple concept. Very simple concepts. What else is coming next? Let's check. Left hand derivative, right? Left hand derivative. How do we look at it? So obviously when we approach the same point C, same point x equals to c from the left hand side. So how we write it as? X tends to c minus. X tends to c minus. So derivative of the function, okay, at c minus is given by f of x minus f of c upon x minus c. And how we modify the limit? By writing it as c minus b. By writing it as c minus b. Okay, please check. C minus b. So how will this look like? Please, how will this look like? It will look like this. So please check here. So c plus b minus fc. C minus b minus fc. Please check here. C plus b minus fc for the right hand limit, and over here c minus b minus fc for this. So how will we write this? How are we getting this minus b? So c minus b minus c. So c goes out. What is left? Oh, only minus b is left. Okay. So that's why. So if you want, you can write it as c minus b minus c also. That also is true. Okay. So I hope you understand this. So for the right hand limit, we write it as c plus b minus fc upon b, and for the left hand limit, we write it as f of c minus b minus f of c upon minus b. Okay. I hope you understand this. Representation looks like the same way. Okay. Representation is this: f dash of c minus f dash of c minus. F dash means derivative. This f dash, I wrote it here. F dash was the symbol. I either write it as f dash or write it as y dash or write it as d of dx for f of x or write it as d of dx of y. So all these are symbol of derivative. All these are symbols of derivative. I hope you understand this. I hope you understand this. Okay. Now, so we learned first thing that we knew, that if first principle, from the first principle, the expression that we got, if that is existing, that limit is existing and it has a finite value, then we'll call the function is differentiable at the point C, right? Again, we learnt about LHD and RHD, the left hand derivative and right hand derivative. Okay, now when can we call the function differentiable? Whenever this, what does this represent? Please check here. This is nothing but my RHD. Please check. The differentiable, the differentiation of the function f at C plus means RHD. The differentiation of the function, okay, C minus, okay, a function fx at C minus means LHD. So whenever we have this left hand derivative and right hand derivative equal to each other, then we can call the function to be differentiable. So basically, if you have to summarize this, if LHD is equal to RHD, then what happens? Then at, let's say, x equals to C, then function fx is differentiable, sir, at x equals to C. At x equals to C. Okay. Remember, something like this we learned in continuity, right? So if the function, the left hand limit and right hand limit was equal and also equal to the function's value at A or value at C, whatever the point we have taken, then we call the function to be continuous. The limit should exist and the limit should be equal to what? Limit should be equal to the function's value. In this case, not the limit, the first principle statement, that should exist for both left hand side and right hand side, and then we can call the function to be differentiable. Okay, we'll see some examples. Okay, can we? All right, let me try to give you example over here, then we'll go to these points. So if I take a function y equals to sine x, it's a function, right? It's a trigonometric function. How does the graph look like for this? Okay, something like this. This is the graph of y equal to sine x function. All right, so let's check the differentiability at x equals to pi by 2. At x equals to pi by 2, which is 90 degree. Pi by 2 is 90 degree. So this is the point. Please check. X equals to pi by 2. What's the value coming for the x equal to pi by 2? All of you know this. This is nothing but 1. This is nothing but 1, right? Yes, sir. Yes, sir. This is 1 only. Yes. Now, please check if I am finding the differentiability value. Okay. What I'm going to get if I find the limiting value on the right hand side? I'm going to get what? Something. So I'm not applying the first principle over here. I'm trying to show you from the limiting condition only. If you check here from this side, okay, what is happening? The value is very close to 1 only, no? Close to very 1 only. And over here, what is it? Close to 1 only. So both sides is gonna be equal. Both sides going to be equal. If you apply this condition, f of x plus a minus f of x upon a, this is for RHD, this is for RHD, and if you apply same thing for LHD, which will look like f of x minus a minus f of x upon minus a, you'll get both these values equal. Okay, so the function will be, this function y equal to sin x will be differentiable at point x equals to pi by 2. Differentiable at point x equals to pi by 2. I hope you understand this. Okay, now let's take some notes. A function is said to be differentiable function if it is differentiable at every point in the domain. Okay, obviously. So for the given function, for this, for example, this function only, y equal to sin x, what's the domain, sir? What's the domain of this? Domain is all real. Domain is all real, right? So for this function to be differentiable, it will be differentiable in all domains. If you keep moving like this, okay, keep moving like this. All right. If you check here, every place it is differentiable. There's one more way to understand the differentiability. Means for the same point, if you draw a tangent, okay, means at a point you can have only one tangent. You cannot have two tangents. So if you draw it like this, you'll get only one tangent like this. Okay, correct? Same way for this point, like this. So if you keep moving, you'll get the tangents like this only. So tangent should be, at a point you should have only one tangent. Okay, at a point you should have only one tangent. All right, so okay. So if you check for this function y equal to sin x, you'll get at every point whenever you're checking the differentiability, you'll get only one tangent at that point. Okay, let's move on. Second point, if a function is differentiable at each, means whenever it is true for x equals to r, means whenever it is true for entire real numbers, then we'll call the function to be differentiable everywhere. For example, this question only, y equal to sin x is differentiable everywhere in this domain, so we can call this differentiable everywhere on the real number, moving on. Okay, relation between continuity and differentiability. All right, means what are the relations that exist between, okay, means these two functions, like these two operations. When can we call the function continuous but not differentiable? When can we call the function differentiable but not continuous? When can we call the function both continuous and differentiable? We'll see. Okay, so if a function fx is differentiable, acha, one thing, if the function is differentiable means it will be continuous also. Please check the previous curve. I said the function is differentiable everywhere. Okay, it was differentiable everywhere in the domain, everywhere in the domain, right? Isn't it continuous also in everywhere in the domain? The function is continuous also, no, in everywhere in the domain. Yes, sir. Okay, so whenever the function is differentiable at a given point, then it is going to be continuous also. It is going to be continuous also, sir. If it is differentiable, then it will be continuous also. Okay, at that same point. Now if the function is not differentiable, then it will not be continuous also. This is simple rule, very, very simple rule. Differentiable, then it will be continuous. Not differentiable, not continuous. Not differentiable, not continuous. Okay. Acha, one more thing. I said ulta. Not differentiable, it may or may not be. It was actually ulta. So I'll just explain you again this part. If it is differentiable, if a function, let's say I have a function fx, if it is differentiable, yes, then it will be continuous also. It will be continuous also. And what is the other way around? If the function is not continuous, then it will be not differentiable straight away. So this is the conditions. Differentiable, then continuous also. If it is not continuous, then it will be not differentiable. What is the other way around? If the function is differentiable, then it may or may not be continuous. Okay, it may or may not be, sorry, if the function is, again I say the same thing, if the function is not differentiable, then it may or may not be continuous. It may or may not be continuous. So both condition might exist. So I'll repeat. Function is differentiable means continuity has to be present. Function continuous, it is not continuous means differentiability not possible. Okay, this is the prerequisite. For the function to be differentiable, it must be continuous. Please understand this. For the function to be differentiable, it must be continuous, sir. If it is not differentiable, then if function is not differentiable, then it may and may not be continuous. Let's take an example. Okay, so I'll just draw here. I'll draw a graph. Let's say I'll take for this y equal to mod x. Y equal to mod x. How will the graph look like, bacha? Graph is going to look like this. Now please check. So if I draw the tangent at the point x equals to 0, at the x equal to 0 from the right hand side. So I'm trying to find out right hand derivative. Okay. So if I draw the tangent for the point right next to this 0, right hand derivative, so I'll get this as my tangent. This is my tangent 1. Tangent 1 for my for a point when I'm closing to right hand derivative. When I'm doing the same thing for the left hand side, like this. This is my tangent 1. This is my tangent 2. So if you check here at the same point x equal to 0, in close proximity, I'm getting what? Two different tangents. So I have two tangents, t1 and t2. I said for a differentiable function in any place in the domain, it should have, every point should have only, like any point should have only one tangent. So but at point x equal to 0, if I try to move little bit also towards right for the right hand derivative part, what's happening? I'm getting a different tangent. Please check. This is my tangent, right? What is the tangent? Means for a point, for this curve, I take a point. Tangent means it should be like this. The point of contact should be only at one place. Same way if I'm drawing like this, I'll get for this point, for the point right next to x equal to 0, this is my tangent. Right before it, I get what? Two tangents. Means at the same point x equal to 0, I have two tangents existing, right? I have two tangents existing. In that case, the function is not differentiable. Differentiability? No. What about continuity? Yes, sir. It is a continuous function because if you find left hand limit, not LHD, if you find LHL, what's the value right before 0? Is 0 only, no? What about RHL? Right after 0 is 0 only, right? Is 0 only, and function's value also is at 0. So f of 0 is also 0. So please check. LHL is 0, RHL is 0, and function's value also is 0. Means function is continuous. Function is continuous but not differentiable. Why continuous? Because f of 0 is 0, LHL is 0, RHL is 0. Whereas in case of differentiability, if you draw the graph right before and right after at the point x equal to 0, means what will happen? You'll have two different tangents. That is not possible. For a differentiable function, at one point there should be only one tangent. There should be unique tangent. Okay. So I hope this is clear. Okay. Now let's read this part. If a function fx is not differentiable, it may or may not be continuous. Okay. Now for function fx is continuous, then it may and may not be differentiable. Correct, right? I took the example, no? Continuous function but not differentiable. Okay. Previous example, if you say continuous function and differentiable, means I can have both the conditions. For a continuous function, it may be differentiable, it may not be differentiable. Okay. Last point, if function is discontinuous, then it will not be differentiable. If the function is discontinuous, then it is not differentiable. So this situation, not continuous, not differentiable. Differentiable, continuous. Continuous may or may not be differentiable. I hope this is clear. I've taken both the examples, so explaining the same point. Alright, please check this. So function's derivative, what does this represent, bacha? Okay, so basically at x equals to a, we are trying to find what? LHD, right? Left hand derivative, no? Left hand derivative, right? F dash of a minus 0 is finite, then fx is continuous at x tends to x equals 0 from left, right? It is continuous, right? Okay, it's continuous. I read this to be differentiable. Okay, means if I'm finding this limit value, if I'm finding this value f dash of a minus 0 and I get a finite number, then I can call the function to be continuous from which end? From the left end. And same goes with a plus h, then we'll consider from right hand. At a, means at point a, at point x equals to a. Okay, if this limit a plus h or a plus 0 exists finitely, then I'll say function is continuous directly from the right. Okay, if the other way around, f dash of a minus 0 represents, and it is represents a finite number, then I'll call it is continuous from the left side. Okay, left side. So you won't have this application, so I'm not taking application of these concepts, these two concepts today. Maybe I'll take some questions on these two and explain it to you as well, okay, in the coming sessions. Now we'll talk about differentiability of the function in an interval. Means for the interval, what type of interval exists? One is closed interval, other is open interval, other is open interval. So we'll try to see for both of them. For the closed interval, what happens? If I'm trying to take, means obviously at every point in the interval the function should be differentiable, correct, right? Means whatever values are there between a and b, 1 2 3 4, whatever it is, for all those points function should be differentiable. But at the point a, my RH ratio exists. Please check. At point a, can I check LHD? I cannot check, bacha, right? Because before nothing is not part of the domain only. I said a function is differentiable, then it has to be differentiable in its entire domain. Okay, domain is what? A to b. So if I go left of a, it's not part of the domain, right? So only we have to check for right part. That's why we are saying we check the differentiability only at x equals to a from right side. Please understand this, because left of a is not part of the domain, so we only check from the right side. Same goes with x equals to b, because at b we don't have a right hand value. Anything right of b will be not part of the domain, so we'll check the differentiability at b from the left side, So you will write this expression. Please check here. This is for a plus, because right of a you are finding it out, and this is for b minus, because you're finding out from left of b. Okay, so if this is true, and apart from these, at every single point between a and b it is differentiable, then I call the function differentiable in a and b closed interval. I hope you understand this. For a function to be differentiable in closed interval, every point in the domain it should be differentiable, and at a it should be differentiable from the right, at b it should be differentiable from the left. I hope this is clear. Okay, now what about open interval? Again same thing, a and b are not inclusive here, so we'll take the differentiability at the point or at all the points lying between a and b. So at all those points the function should be differentiable. So at all those points between a and b the function should be differentiable, bacha. When we have that situation, then we can call the function to be differentiable in that open interval a comma b. Okay, so a comma b is simple to understand, but for this part hope you understand this, because left of a nothing is there, that's why we only check the RHD at a, and at the right of b nothing is there, so we check only LHD at b. Okay, same concept was used in continuity also, pardon me. So I can move on from here. Let's see. Now we moved on to our coming part, which is what? General theorem. As I said, we'll see how what are different operations performed in mathematics. For example, we have multiplication, differentiation, divisibility, division is there. Okay, then other multiplying a constant term. So for all these operations, how the differentiation changes, or whether it changes or not. So let's see. So first one, whenever we have a constant, okay, and we are finding differentiation for this, if I have to find differentiation of 2, 0, differentiation of 4000, 0, differentiation of log of 4000, 0. Okay, so all these values, please check here, constant. For all these constant, differentiation is always a 0, okay. What about non-zero? When we get non-zero? Whenever we have some variable in it. Now let's look at first property. So let's say in this function, this is a constant multiplied like this. C is multiplied to f of x, and we have been asked to find the differentiation. Right? Yes, we have been asked to find the differentiation, sir. So what we can do is simply take the c out. Like this. For example, if I have y equals to, let's say, 2x, y equal to 2x, then differentiation of this will be simply dy by dx will be what? 2 times of dy by, forgive me, differentiation of x with respect to x, which is nothing but 1, So what is my answer? 2 times of 1. How much is that? 2. How much is that? 2. Okay. Whether I take another example, so let's say y equals to, I take 15 sin x. What will happen? Just take dy by dx. If I'm asked to find the differentiation, I'll take 15 outside and write like this: differentiation of sin x with respect to x, right? Sin x with respect to x, what I get? 15 cos x. 15 cos x. This is my answer. So if I have a constant multiplied to the function, I can simply take the constant outside and do the differentiation, whatever the rule that we have, a formula that we have for that particular function. Alright, let's check the product rule. What's there, bacha? If I have two functions fx and gx, are there, okay, and they're multiplied like this. So if I have a function fx and gx, okay, both are differentiable, okay, both are differentiable function, then they are given in product. If they are given in product, how do you apply it? So what you're going to take, keep the first function as it is and take differentiation of the second function. Keep the first function as it is and take differentiation of the second function, and then add, then put a plus sign and take what? Keep the second function as it is. Please check here, first function, second function. So first is kept as it is, taken the differentiation of the second one, second function as it is, taking differentiation of the first one. Yes sir. Okay, what if we have more than two functions? What if we have more than two functions, fx, gx and bx? What are we going to do then? So if we are asked to find the differentiation of fx, gx and bx, we'll take what? So we'll take the differentiation of the first function, keep the other two as it is. Differentiation of the second function, keep the other two as it is, and the third function. Basically, take the differentiation of any one function at a time and then keep the rest of it, as it is. And make sure that you're taking differentiation of all the functions at only once. So see, if you see here, fx differentiation is only once. Next is what? Differentiation of gx. Next is what? Differentiation of bx. So every function differentiation is taken only once. Yes sir. Okay, one more thing. Let me add here. That's what I'm looking for. If I have this operation, fx plus minus gx. Okay. If I have this operation and we are asked to what, bacha? We are asked to find the differentiation of this. Fx plus minus gx. What we're going to do is simply write it as differentiation of f of x plus minus differentiation of g of x. Basically, if I have sum or difference of two different functions, okay, both should be differentiable, and we are asked to find what? Derivative of that operation, derivative of that composite, that application of the two functions. Then we can simply write the derivative of the first function and then add or subtract with the derivative of the second function. Okay, so this was what missing over here. I wanted to add it over. Okay, quotient rule. If fx and gx are, okay, differentiable. If fx and gx are differentiable and gx is not equal to 0. Why sir? Because if you check here, it's in denominator. If it is 0 means the function will become undefined, right? So fx by gx, if it's given like this, and we are asked to find the derivative of this function, derivative of the function fx by gx, then what we do is, this is called as quotient rule. Previous one was, this was the product rule, sir, where the function was multiplied. Okay, this is when we add or subtract. Now next one is when we have quotient, means the function is given in division. Then what we do, keep the second function as it is, take derivative of the first function. Please check here, second function, the denominator, keep it as it is, and take derivative of the first function which is in the numerator. Then with the minus sign, keep the first function as it is, and derivative of the second function divided by square root derivative of second function. Now let's look at some examples. Okay, I know I'll tell you the rules again later, but let's look at some examples first. So we'll look at for the this one. For this one, we'll look at first sum of or difference of two functions. So if I have a function y given as let's say 2 plus sine 2x, then how will you solve this? Correct now? This is also a function, a constant function. This is a function in, this is a sine 2x, right? So let me simply take it as sine x. Let's not go into chain part right now. Okay sir, simply sine x. How will I take this derivative? So this y dash will become what, bacha? This is the way of writing derivative, right? I can write it as dy by dx or y dash. This will become what? Derivative of 2 plus derivative of sin x, derivative of sin x. This will be simply 0, this will be simply cos x. What's my answer? 0 plus cos x is cos x. Okay, simply 0 plus cos x is cos x. What about this? If I have this function like this, if the y was given by 2 upon sin x, 2 upon sin x, how will you do this? Using quotient rule, how will you do this? Simply I can take it as y dash to be, I'll take 2 differentiation, I'll keep this one as it is, sin x I'll keep, because you check here, the denominator, the function in the denominator is kept as it is, so sin x is kept as it is. Now what are we gonna do next? Differentiation of 2, right? Then a minus sign will come, then I'll keep 2 as it is, and I'll write it as differentiation of what? Differentiation of sin x, correct? I'll keep the first function, which is 2, as it is, and then differentiation of the second function, so differentiation of sin x upon second function is a square, so sin x square, sir. What I get, bacha? I get this is 0. Why, sir? Constant differentiation is always 0, so 0 times anything will be 0 only, minus this will be simply 2 cos x. Differentiation of sin is cos x, so 2 cos x upon sin square x. Okay, so this will become what? Minus 2 cos x by sin x will be what? Cos by sin will be what? Please check. Cos by sin, sir. What is I'm getting over here? 2 cos x by sin square x. Simply it is minus 2 cot x times cosec x. Cosec x minus 2 cot x times cosec x. Please check. Minus 2 cot x times cosec x. Why, sir? Because one sign will become cos by sin, so cot, another will be 1 by sin, so cosec x. Okay, so I hope this is clear. Alright, next theorem that we have is very important theorem. Okay, others were also important, but they were very simple. Okay, at times what happens in the questions, we forget this theorem, chain rule, but we should not. Otherwise, you know, even after putting all the efforts, your answer will be incorrect. So what happens is, if we have, so if you remember, I wrote something in the previous question and then I erased it, sin 2x. Okay, if I have two different functions, one is y sin 2x, another is y equal to simply sin x. If you write this as y derivative as cos x, and over here what are you gonna write? Y derivative as cos 2x. What will happen? No, that this will be correct and this will be incorrect. Sir, how? Same rule we applied, right? Y derivative, y is sin x, so y derivative is cos x. Y is sin 2x, so y derivative is cos 2x. How is this right and this wrong? Because automatically over here chain rule is applied, but over here to apply the chain rule. Here we don't need to apply because it is automatically applied. Okay, even without knowing it, you have applied the chain rule, but in this case you have not. Okay, we'll see what it is. Okay, so what happens is, whenever we have composite functions, check here. So I have a function y given as f of u, means function of u, but I also have a function u given as, so I have a function y given as function of u, the variable u, but u is also a function of x. Okay, then I can simply write y as function of u. I can replace this u by function of x. Okay, now if you see here, I have two operations, I have two functions here, f of phi of x, this is phi, right? F of phi of x. So how will you solve this? So first you have to find derivative like this. Please check here. So you will do like this. First you will find derivative, because the function, for the function y is not written in terms of x. Please check. The function y, is it written in terms of x? No, sir, there is no x here. There is no x here. We don't have x over here. Okay, then how will you find derivative with respect to x? We can't find, sir. X is missing over here. We can't find, sir. But if you write it in the composite form like this, f of phi of x, then x is present here. So what we do is, we write this, whenever we are finding a differentiation of this function y with respect to what? With respect to dx or x, what we do is, we first take the derivative with respect to y, u. Take the derivative of y with respect to u, and then we move on to taking derivative of u with respect to x. Derivative of u with respect to x. So this becomes a chain rule. So what happens, what I'm trying to say here is, if I take the same question, example, please check here. Okay, so first is y equals to cos of 2x. Means first function is cos, second function is what? 2 times of x, right? First function is cos, so trigonometric function. Second is what? A linear function. Please understand this. First function is trigonometric function, second function is linear function. So how will we deal with it? So first we will take this. Please check. So if I write this as y equal to cos u, y equal to cos u, and then I write it as u equal to 2x, u equal to 2x, then what I am saying over here, please check. I am saying that dy by dx is equal to dy by du, dy by du times du by dx, sir. Please check. I am asking you to do dy by du. First write with differentiation with u, then du by dx. Please check. dy by du times du by dx. Okay. Okay, sir. Understood. Alright. Let's see more steps. How will this look like? So I will have this dy by dx equals to dy by du means what? Differentiation of cos 2x, right? Differentiation of cos u by du. Okay. Into differentiation of du means what? Differentiation of 2x by dx. Okay. Right, sir? Right, sir? How will this look like, bacha? How will this look like? So where can I write this? Can I write this over here? I hope you can see this. Can I write this over here? Last page. The differentiation of cos will be simply minus sign u. We'll see how right now. We'll see how right now. And differentiation of 2x will be what, bacha? Simply 2. Simply 2. How, sir? I can take 2 out. X power 1 will be coming as 0 only. It will become minus 2 sine u. It will become minus 2 sine u. This is the end of your chain rule. First, let's see what do you call the rules. As I said, let's see the other rules, and then we'll move on to solving more problems. And if you want me to clarify this, please comment that such chain rule is not clear. Ask me, because this is very important. Okay, this is very important. See, for this sine x, for cos x, what happens? There was no constant, there is no coefficient of x. So simply it was only 1. So if you write this as, y derivative equals to cos u into 1, what will become? Cos x times 1. Because 1 is nothing but simply 1. So I'll get y equal to, y dash as cos x, please check. Y dash as cos x, because there was no 2 present there. So simply that was, the coefficient was actually 1. So you, without knowing it, you use the chain rule and got the answer as this thing. That's why there's a difference. There's a difference. Alright, let's move on. So let's look at some rules now. Okay, I use few questions. In the few questions I use sin x and x differentiation. But let's look at all the differentiation rules. Okay, that is going to be useful for us in today's session and for the coming sessions as well. So first one, for the first one, the simplest one. Okay, differentiation of x power n. X power n. Alright, what will this look like? If I'm writing, let's say, a constant also with it, a times of x power n. I hope this is visible. Yes, sir, this is visible. Okay, this will become what, bacha? Take a outside, and then will be n power x power n minus 1. Okay, this is my differentiation of any polynomial function given in this format. Okay, this x can be written like this also. Anything. This x can be cos. This x can be another polynomial ax plus b. Anything is okay. I can write this x as this too. Anything. I can write this as x anything. But if it is in the polynomial form, then we use this simple formula. I hope this is clear. Okay, let's move on to the second one, which is nothing but your first one. Second one is differentiation of exponential function e power x. Answer will be simply e power x. Nothing is there. E power x only. Third one, differentiation of a power x. What will happen? You'll have a power x log a. A power x log a. Okay. What happens next? Fourth one will be what, bacha? If you have differentiation of, let's look at this, ln x. Differentiation of ln x. What will happen to this? 1 upon x. Alright. Next, let's look at some formula from trigonometric side. So we will learn these functions in detail, okay? We'll learn these functions property, exponential, logarithmic in detail in the coming sessions. But just so that, because what will happen now when we are solving a question, these formula will be used. So I want to recall all these concepts. I want to make sure that you know all these formulas, you have all these formula at one place so that you can use it in the question, okay? So we're going to discuss exponential function, logarithmic function, trigonometric function, inverse trigonometric function in detail in the coming sessions. But today, let's have these simple formulas with us so that we can solve the questions. So d of dx of, let's do the simplest one first, sine of x. Sine of x is given by cos of x. What about the next one, sixth one? D by dx of cos of x is given by minus sine of x. Minus sine of x. What happens to the next one? D by dx of tan x. Tan x, what will this be, bacha? Simply secant square x. Secant square x. Tan x differentiation is secant square x. What about the next one? D by dx of cot x. Cot x will be what, bacha? Minus cosecant square x. Minus cosecant square x. Ninth one, d by dx of, what is left? Sine, cos, tan, cot is done. We have sec x also. We have sec x also. What is this going to be? Sec x tan x. Sec x tan x. Next one, I think the last one is d by dx of, what is it going to be? What is left? Cosec x. Cosec x. You'll have what? Minus cosec x and cot x. Cosec x minus cot x. Please check here. Alright. So yes, for sine we have cos, for cos we have minus sine, for tan we have secant square, for cot we have minus cosecant square, for sec we have secant tan x, for cosec we have minus cosec x minus into cot x, minus cosec x into cot x. I hope this is visible. Please have a look. Please have a look. Okay. Any doubt, any discussion in this, comment below. Okay, I will check whatever is the requirement. We will answer those doubts as well. Please check. Okay. Now we have a question here. So I want to give you a question. Let's solve this. Y equals to, if I have this condition, x to power x. Y equal to x to power x. This is a good question. Okay. How are we going to solve this, sir? How are we going to solve this, sir? So if you want to solve it from your side, pause the video here, solve it, then come back to the solution and cross check whether you're getting the same answer or not. Okay. Please check. Please take a pause. Okay. So let me solve it now. So how will this look like? So you can see right now it looks none of this form, right? So we have a power x, but this is not a power x, it is x power x. The variable is repeated x power x. So so then what can we do, sir? Okay, take simply ln on both sides. Take simply ln on both sides. You'll see, remember this property of ln. I'll come to the property later, but let's take the ln right now. So ln of y will be equal to what, bacha? Ln of x to the power x. Correct. We know that if I have this ln of a to the power x or anything else, a power b also, a power b, this becomes what? B ln a. B ln a, right? So this will become what, bacha? Please check. Ln y, it looks different, something different. Let me write it properly. So it becomes ln y equals to what? This x will come here. So x ln x. X ln x. Now can we differentiate? Yes, sir. Okay. So how will you differentiate over here? Take this d ln y dx equals to d by dx of what? X ln x. X ln x. Please check, multiple rules are being applied here. First we use what? We use the log on both sides, natural log on both sides to get this expression from that formula. Okay, but now from that relation we got this expression x ln x. But now you check here, what are you going to do for this part? Differentiation of ln y. Differentiation of ln, what happens? 1 by y. Simply 1 by y. I'll write it as 1 by y dy by dx, sir. Why dy by dx, sir? Because please check here, this function is not in the form of x, it's in the form of y. So I have to write this this y also, I have to do the differentiation of y also, right? So dy by dx, please understand. Okay, chain rule we have to apply. This y is not in terms of x, so I have to do that in terms of y. I get 1 by y, and then, so basically what I've done here, if you want to know the steps, I have done it with the help of chain rule, like this: d by dy of ln y, and then dy by dx. So this part is being replaced as, this part over here is replaced as 1 by y. Correct? That's the formula, no? D of, please remember this formula, d of ln x with, this is ln x with dx is what? 1 by x. Same way, d of ln y by dy is what? 1 by y. So I can replace this whole thing by 1 by y. 1 by y equals to, over here, product rule, sir. Two functions are multiplied. fx is x, gx is ln x. fx is x, gx is ln x. So I can do what? I'll take the first function differentiation. So I can write ln x as it is. And second one will be what? Differentiation of first plus sign. Take x as it is and differentiation of ln x. Please check. Product rule, right? I took the differentiation of the first one, second I kept as it is, ln x. Second one I kept the differentiation of ln x and kept x as it is. Okay, what I'm gonna get? 1 by y dy by dx equals to, this will be what, bacha? Simply 1, because differentiation of x is going to be 1, so I have it as only ln x left now. Over here I'll have what? X times of, what is this, the differentiation of ln x? X is as it is, differentiation of ln x is 1 by x. So I get x and s out. Please check now. Please check over here. So I have 1 by y dy by dx. 1 by y dy by dx equals to 1 plus ln x. 1 plus ln x. Please check. 1 plus ln x. 1 by dy by equals to 1 plus ln x, right? Now multiply y on both sides. Why? Because you have to eliminate this y. So multiply y on both sides. Whole thing you multiply y. What are you gonna get? Y times of 1 by y dy by dx equals to y times of 1 plus ln x. Am I right? Yes, sir. Cancel this y and y, bacha. What I get? Only dy by dx equals to what? What is my y value? Why my y value? Please check here. My y value is x power x. So x power x this is my answer. So for the given function y, we were asked to find what? Differentiation, which is nothing but dy by dx. How we got this as? All these steps. Okay. Now sir, you might ask, sir, why this question? Is it a p by q? No, it's a question where we have all the concept being utilized what we learned right now. We learned the formulas, we learned the formulas of differentiation. We are using that, we are using for log, we are using for x also, exponential also. We are using what? Chain rule, we are using what? Product rule, we are using exponent also as well. Okay, sorry, logarithm over here as well. That's why I took this question. Let's move on. First problem. So we have completed the concept part. Now we're gonna solve questions on it. You know the pattern of the session. First I come with the concepts, explain you that, and then we solve more and more questions. So the first one looks like this: derivative of differentiate this. So basically derivative of this function sec of tan of root x with respect to x. Sec of tan of root x with respect to x. Can we do this, sir? Of course, sir. Let's see how. So basically they have written it as y equals to secant tan root x. Secant tan root x. So forget about this right now. I can take this as a variable t, right? Or theta, right? So what is the formula of, what is the differentiation of sec? Is going to be what? Remember this, sec x tan x. Sec x, differentiation of sec x is sec x tan x. So sec of, let's write it as t, and tan of t. Is it over, sir? No, we have to do it for this part also, right? So we'll write it as differentiation of t with respect to what, bacha? X. Correct, no? Chain rule. First part was the differentiation of sec. Now comes the chain rule. So we have to find out dt by dx. This is my very important first differentiation. Please check dt by dx. Now what are you going to do? Find dt by dx. So what's my t? Tan root x. So my dt by dx will look like this. Differentiation of tan root x by dx. Right? Right, sir? Confused, sir? Confused? Please check. I can take this as theta also. Check this as theta also. This will become simply tan theta. What is the definition of tan theta? Sec square theta. I'll write as sec square theta. Okay, what is theta? So, write as theta only. And then what? D theta by dx. D theta by dx. Again, chain rule. Why, sir? Because this we have to do again. Right? D theta by dx. Alright. Please check. This is my dt by dx. Last part is what to be done? D theta by dx. D theta by dx. What is my theta, sir? Simply root x. Simply root x. What is the answer? Please check. Differentiation of this. What does this mean? 1 by 2. Okay, we know this. What's the formula? N comes out. N times of x power n minus 1. What's the formula? N times of x power n minus 1. Exponential function. Sorry, a polynomial function. So 1 by 2 will come out and this will x will be 1 by 2 minus 1. How much is that? 1 by 2 and x power minus 1 by 2. How much is that? Simply root x. Simply root x. So I can erase this and write it as root x. I hope you understand this. I hope you understand this. Now I have all this thing. I'll club it together. First I'll put this. First I will put this over here. I'll put the theta value back. So what I'm going to get dt by dx? What I'm going to get dt by dx as? I'll get here as sec square of what? Theta is what? Root x. So root x times what? This value, theta by dx. Theta by dx, how much is that? 1 by 2 root x. 1 by 2 root x. Now I'll take this and put it here. So what is that? Please check. So my simply y dash is going to be sec t tan t. What is sec t tan t? So sec t is my this value. So I'll write it there. Tan root x. What next? Tan t. So again with tan, this is one thing. Okay. Tan looks complicated. I hope you can understand from here only. No, don't have to draw the brackets. So I'll just write a multiplication symbol every time. So multiplied with tan t. So again what will come? Tan t is how much? Tan root x. So tan of tan root x. Right? What is next one? dt by dx. So dt by dx is this value. So sec square root x. What? Times what? Again 1 by 2 root x. Okay. If you want to simplify this, take this 1 by root x right here. 1 by 2 root x I have written here first, and then simply this also I write it over here only. Sec square x. Okay. And the rest of the things. Sec tan root x and please check here. Sec tan root x, this part, times tan root x. What is this? This is basically my t and t. Write it here. Write it here. I hope this is clear. Simple question. Use of chain rule. Use of chain rule. First for sec we did, then for tan we did, then for root x we did. If you want, if you don't like to do it like this in the step, you can simply do it like this. Sec of. So take simply, don't have to do t and substitution and all. Simply you can do it as in one go. You can write all the answer in one step also. Okay. How will I write one answer in one step? Please check. Sec definition. What's the definition of sec? Sir, it is going to be sec of the same thing. Tan root x. Tan of tan root x. Right, sir? So for sec we did, for the sec part is done. For tan part will be, sir, sec square root x. What about root x part? Simply, sir, 1 by 2 root x. So you don't have to do all the steps. If you can understand from here, you can write this step or is also right answer. This step is also correct. If you check, same thing I've got here. Same thing I've got here. Please check. Okay, let's move on. Problem number 2. Prove that the function fx is differentiable at fx is a function given by this not differentiable at x equals to 1. Not differentiable at x equals to 1. Please check. When can we call the function to be differentiable, bacha? If you remember, whenever we have LHD equal to RHD. I said this in the beginning only. Whenever my left hand derivative is equal to right hand derivative. Okay, sir. How will you write the right hand derivative if you remember? It was given by limit f of a plus h minus f of a upon a when h tends to 0. Correct? Right hand derivative f of a plus h minus f of a upon a, right? Okay, sir. What is my a in this case? Please check here. This is my a, right? So my a is equal to 1. So please put it here. Please put it here. So basically what will happen? I'll get limit f of 1 plus h minus f of 1 upon, what is it? Simply 1. Simply 1. Now please check. What is my function? Mod of x minus 1. Mod of x minus 1. So I can write this as, okay, sorry. Yeah, I can write this as same thing. Limit h tends to 0. This will continue. Limit h tends to 0 will continue like this. F of 1 plus h means wherever is x, replace this x by 1 plus h. So this will become what? Mod of 1 plus h minus 1. Please understand. Wherever is x, replace that by 1 plus h. So mod of x is replaced by 1 plus h. So I wrote it as 1 plus h. And this minus 1 is there. So minus 1. Close the mod, please. Okay. Now minus f of 1. F of 1 means wherever is x, replace it by 1. So I write it as 1 minus 1. Divided by 1. Please check here. This is 0. This is 0. What I get here now? Simply I get here as, this also cancels. This also cancels, right? Correct? 1 minus 1 is cancelled. What I am getting here is limit h by 1 where h tends to 0. What is the answer? Please check. Answer is 0. Answer is 0. Correct? 1 plus h minus 1. Answer is 0. Correct? No, sir? Yes, sir. Correct? Alright. Okay. Okay. There is a mistake, sir. This is not A. This is not A. This is H, sir. This is H. I was thinking. This is H, sir. Everywhere. Forgive me. This is H. Okay? This is H. So what's my answer? Answer is not 0. Answer is 1. When I got the answer 0, I got confused. Answer should be 1. What is my limit? 1. So what is this value? This value is my RHD. Please forgive me, I made a mistake in the formula of RHD. It should be f of a plus h minus f of a upon h. How, sir? Remember this, it was nothing but like this, no? A plus h minus a goes out, answer is h, right? So a plus h minus a, okay? I hope you understand this. Forgive me for making this silly mistake. Alright. So same way we will find LHD, sir, because we have to get this expression. So LHD, how will we get, sir? Same way. In this condition, we'll write limit f of a minus h minus f of a upon minus h where h tends to 0. Please understand this. How I'm getting this minus h? So a minus h minus a goes out. I have what left? Minus h only. I have what left? Minus h only. Okay. Chali. This is coming from first derivative principle. Okay. First principle of derivative. So if I do this, substitute here. What is a value? A is 1. So I get what? Limit. What? I can write this f of 1 minus h minus f of 1 upon minus h where h tends to 0. What I'm going to get? Again limit h tends to 0. This will be simply what? 1 minus h minus 1, and this will be simply what? 1 minus 1 upon minus h. Please understand this. A is 1, no? So I can replace in the function x as h minus 1. So 1 minus h as 1 minus, so x as 1 minus h, and this will be 1 minus 1. This is simply 0. This is getting cancelled. So 0, 0. This also will cancel each other. 1 minus 1. What is left over here? I have this left. Limit h tends to 0. Mod of minus h minus 0 upon minus h. How much is that? Mod of minus h is positive of h. Mod of minus h is positive of h. Cancel it. How much is the answer? Minus 1. So please check here. My left hand derivative is what? Minus 1. Right hand derivative is what? Plus 1. Are they equal? No, sir. They are not equal. Means not differentiable. Not differentiable. So we have got the RHD as 1, LHD as minus 1, left hand derivative as minus 1, and they're not equal to each other. It means the function is not differentiable at the point x equals to 1, x equals to 1 or a equal to 1. Moving on. Can you move on to the next problem? Okay. Let's see. Alright. Prove that the greatest integer function defined by, this is a very simple question. Again, can you look at the graph quickly here? For GIF, graph is the answer. For GIF, graph is the answer, sir. Don't have to do anything. Look at the graph. No need to do anything, sir. Yes, sir. Yes, sir. How is it? So I'll do for point 1. Point 2 you can do by yourself only. Not a big thing. So for point 1, how will it look like? Please check. 0. Function at point 1 will look like this. Next one will be what? Correct. Now I'm doing for only this point. This point 1. Okay. This is 1. Alright. So if I check the left hand derivative, so I can use the expression also. Not a problem. If I do like this, 1 minus h, what will be this? If I find, let's say, what is the first principle saying? F dash of a is given by f of a plus, sorry, yeah, okay, forgive me. Yes. So this, yes, f of x minus f of a upon x minus a, right? So if you are going to the point before a, before 1, before a is what here? 1. Before 1, what is the value? Before 1 value is 0. After 1 value is 1. After 1 value is 1. So if that case, right before 1 value is 0, right after 1 value is 1. So they are not equal to each other. Okay, you'll get not equal to each other. Other way, from the graph, I was doing from the graph, right? Let's understand from the graph only. Before 1, draw the tangent. Before 1, add for the function before 1, draw the tangent. How will it look, picture? Tangent is this, right? Right? After 1, what is the tangent? This, right? Is it the same tangent? No, sir. This is my tangent 1, this is my tangent 2. Not the same tangent, sir. Okay? T1, the tangent 1 is not equal to tangent 2. Okay? Two different tangents. Tangents at same point. At same point. At same point. So obviously not differentiable. Again, if you want a simpler, much simpler concept, what did I say? If a function is continuous, then only it will be differentiable. If a function is not continuous, then how can it be differentiable? Is the function continuous over here? No, sir. The function has a having break. So if you want to understand from that way, so first thing is to know from the first principle. 3 methods. Method number 1. Method number 1 from the first principle. Apply this principle. Find the LHD and RHD using this concept the way I did here. Please check. Use the LHD like this, RHD like this for the same function. You'll get it not equal to each other. So not differentiable. First way. Second method is what? Graphical method. Graphical method means take the tangents are two different tangents, that's why not differentiable. Third method, method number 3. Method number 3. What is it? Function is not continuous, sir. The function is not continuous at point x equals to 1. At points x equals to 1, obviously then it will be not differentiable. If it is not continuous, then differentiability does not come to picture only. Okay. So even at 2, what will happen? Same way at 2, what will happen? You'll have this condition. Before 2 it will be 1, after 2 it will be, after 2 it will be 2. So the function is not continuous. The limit will not exist at this point. At the point x equals to 2, the limit will not exist. The function will not be continuous. If the function is not continuous, then what will happen? It will not be differentiable also. So at point 1 or 2, what is happening to the function? Function is not differentiable, sir. The function is not differentiable, sir. Moving on. Moving on, sir. Now, yes. So we have taken a lot of questions for, what you call implicit functions. Means there's something called as, if you remember, explicit functions and implicit functions. Okay, I'll give example of explicit function. I'll give example of explicit function. You'll understand from there only what does this mean. If I write this as y equals to sine x, then what it means? I can express y, the function y, in the form of x only. Explicitly means I can write the function y in the form of only x. Okay, so explicit function. Wherever as in this case, can you define y like this? Please check this function. Can you define y like y without x? Okay, just y you can define like this? No, sir. So function is implicit in nature. The function is implicit in nature. Alright, so how to find differentiation of that? Okay, so obviously we will have to use chain rule at multiple occasions. Okay, and other, since there is a product, so we'll have to use product rule also. So let's check it out. We have constants, so differentiation will be 0. Let's check. So apply differentiation on both sides with respect to what? X. Look at the denominator. Derivative of y with respect to x, we have to find it out. So differentiate the entire equation with respect to x on both sides. How will that look like? Please check. So if I, okay, all right, let's see. So for the first one, what I'm going to do? Simply 3 times of x square. How, sir? N is by n, the formula is this, no? N times of x power n minus 1, n is what? 3. 3 will come out as it is, and then x power 3 n minus 1 will become what? 3 times of x power 3 minus 1, 3 times of x square, 3 times of x square. Please check. Please check this. Alright, sir. Yes, sir? Yes, sir. Okay, what about this? So there is a product here. Means we have to use the product rule. Means we have to take one function at a time. So how will I go about that? So let's take only x square at a time. So I'll keep y as it is. I'll keep y as it is. What happened to this thing? Differentiation of x square. How much is that? Same way 2x. Same way 2x. So I can rewrite this as only 2x. Just to show you, I wrote it like this. So differentiation of y x square will be 2x, sir. 2x, sir. This is done. What is the next step? I have to do again for I kept y as it is and did for x square. I have to keep what? X as it is, and do for y now. So that will be simply this dy by dx. This step is done. So these two terms are over, sir. What about the next term? Same we have to do again. For one time I'll do for x, other time I'll do for y. How will that look like? Please check. So when I'm doing for this x, this will be simply what? Please check. Keeping for only x, so I'll keep y square as it is. This is my, yeah, y square as it is. So I'm doing for this. So d of x upon dx. Okay, this will be simply what? 1. So I can replace this by 1. Yes, only 1 is enough, sir. What about next thing? I'll keep x as it is, and this will become what? 2y dy by dx. Correct? For y square I'll have 2y, and for y I'll have dy by dx. Yes, sir. What is the next step? Simply 3y square. Is there x here? No, we have to apply the chain rule. So what? dy by dx, dy by dx. And what about the RHS part? 0, sir. It's a constant. 81 is, so constant is equal to 0. Now please simplify this. This is my first step. Second step will look like what? So I'll write my dy by dx term at one place and other term at other place. Why, sir? Because we're looking to find the value of dy by dx. Value of dy by dx. Please check. Please check. So I'll write dy by dx terms on the left hand side. Please check how much you're getting. So I have dy by dx terms. I have dy by dx terms. Number 1 term, second and third term. Second and third term. So first check this. So I will write like this: x square dy by dx. Next is what? This is what, bacha? 2xy dy by dx, dy by dx. Lastly, plus 3y square dy by dx equals to what? 0 is there. I can remove, I can take all the part on the other side. What is that? X square minus 3x square. What is it? Minus 3x square. What is this? Minus 2xy. Please check this. Please check this. My other terms are this, this, and this, right? 3 terms. So I removed on the other side becomes, I move this thing on the other side becomes what? Minus. This also becomes minus. This also will become minus only. How much that will be? Minus y square. Minus y square. So now I'll take here minus sign common, here dy by dx common. So for the LHS, what I'm doing is taking dy by dx common. Please check. If I do that, I get x square plus 2xy plus 3y square. I get x square plus 2xy plus 3y square. This is my LHS side. What about RHS side? I take minus sign common. I take minus sign common. How much is that? 3x square plus 2xy and plus y square. I want to find what value of dy by dx. This was the second step, this is my third step, this is my fourth step. Dy by dx will be what, bacha? Simply this by this, because this in multiplication. So will become what? 3x square plus 2xy plus y square upon this whole thing. How much is that? X square plus 2xy plus 3y square. I hope this is clear. I hope this is clear. Simple question, not that difficult, but looks like, because it is, you know, in the form of implicit function. So we have to do with the help of chain rule. I hope this is clear. Okay. All right, sir. Find dy by dx equals to, okay, for this function. Again, we have to use what? Chain rule. Why, sir? There is no simple way to write the y. So same concept we can use, sir? Yes, sir. Let's use it. Let's see how can we proceed with this. So apply derivative on both sides of the equation with respect to x. How will that look like, bacha? So it will be 2. Yeah. All right, 1 second. Correct only. 2 sine y, first thing, correct? Then chain rule is going to be activated here. 2 sine y, then next is what? The sine y. First we use the exponential function. Sorry, polynomial functions differentiation. 2 sine y, 2 comes out. Sine 2 minus 1 is sine 1 only. So simply sine y. Next what? For sine y we have to do, right? So it will be cos y. Right? For sine y we have to do for cos y. Next is going to be what, bacha? For y also. So dy by dx. I hope you understood this. There is no x here. I am finding differentiation with respect to x. I am finding differentiation with respect to x. So I am doing first for sine 2y. So like this. If you want me to explain this, I can do it like this. So differentiation of sine square y by dx. Next is going to be what? Differentiation of sine y. Next is what? Differentiation of y with dx. What is this? 2 sine y. What is this? Cos y. And what is this? dy by dx. Same thing is written there, right? Same thing is written there. I hope this is clear. Not required, just to explain you, I wrote it here. Okay. Okay, sir. Let us see. Okay, let's move on. Now what I'm going to do next? I have to do for this part also. So how will that look like? First it'll be minus sine xy, no? Minus sine xy, right? Because cos differentiation is minus sine. So minus sine xy, then I have to do for xy also. So I will do it like this. Please check here. I will write here. I will write over here, but I'll show you over here. So cos xy differentiation will look like what, bacha? So it will be simply sine of xy with a minus sign, of course, and then we'll do what? Differentiation of xy. The product rule we have to apply. Product rule. First chain rule, then product rule is also applied. So minus sine xy. Then what are we going to do? Do for x. So I'll leave just y as it is and do for x. So for that x will be 1, and then I'll leave x as it is and do for y. For y I'll have dy by dx, right? Dy by dx, no? So this is my answer. Y plus x dy by dx. So I'll write it here. Minus what? Okay. So plus actually. Plus sine. Over here what I'm going to get? Minus sine xy. Bracket is there. Y plus x dy by dx. Okay. Equals to what? 0. Because for pi is a constant, differentiation is 0, bacha. Differentiation is 0. This is my only one step. I don't need this part. This is just to explain you how we got this, right? I don't need this part, right? Okay. Okay. Let's move on. Next step. So the negative part, I can move it on the other side. Okay, how will that look like? Please check. It will simply be 2 sine y cos y is what, bacha? Sine 2y. Okay, this is simply what? D by y dx. D by dx equals to what? This will go on the other side, will become what? Plus sine xy y plus x dy by dx. Yes or no? Yes or no? Yes sir. Okay, now do one thing, do the expansion over here. You'll get what? Y sine xy, and then what you're gonna get? X sine xy dy by dx. Xy dy by dx, right? Because you multiply sine xy to the x dy by dx. So like that. Now bring this term over here. Bring this term over here. What are you gonna get? Please check. You'll have this as sine 2y dy by dx minus this thing x sine xy dy by dx. Dy by dx, correct? Now what is left over on the right hand side? I have only y sine xy left. Y sine xy left. So y sine xy is left, bacha. Y sine xy is left, bacha. Okay sir. Let's take the dy by dx common here, because we are looking to find what? Dy by dx. So if I do that, what I'm gonna get? Dy by dx is equals to, sorry, I'm taking common. So sine 2y minus x sine xy, and what is that? Y sine xy. RHS is y sine xy. So bring this thing over here. I get what? This is my step, okay? Dy by dx is equals to, what is this? Y sine xy upon this whole thing, sine 2y minus x sine xy. X sine xy. This is my answer. Please check. Okay. So I had to do it for differentiation of x with respect to, so differentiation with respect to x for entire left hand side and right hand side. RHS is constant, so 0. I had to apply this. I hope you understood this. Okay. How sir? For here it was what? For 3 part we had to do. First for sine square, then for sine y, then for just y. For over here I had to do for first cos, then I have to do for xy product. So I use the product rule over here. Y first kept as it is, then second x kept as it is. We get this expression, simplified it, remove this dy by dx to keep out only one side, because we wanted to find out the value of dy by dx. We got this as my answer. This is my answer. Please check. This is my answer. This is my answer. I hope this is clear. I hope this is clear, sir. Let's move on. Okay. Alright, sir. X square plus sine y equals to y square plus log of x plus y, then find dy by dx. Similar question. Similar question. Okay. So obviously how I'm going to do? I'll do it for this x square. Then I'll do for sine y. No problem in LHS side. I'll have only what over here multiplied with dy by dx. Because y is, the x is not there, no, I have to multiply with the chain rule. Over here again I have to do for the dy by dx. Over here again I have to do for log first. So 1 by x plus y will come. Then I'll do what? For the sum of the functions. So for this, how will it look like? 1 by x plus y, differentiation will look like this, times of what? Times of what? For x we'll do first. So it will be 1, it will be only 1, and for this I'll have what? Y will be dy by dx. Okay. So this way you can just try this question. Okay. Please try this question. First do for x square, then for sine y you're gonna do what? Cos y. For this you're gonna do cos y dy by dx. For this you're gonna do what? 2y dy by dx. Please, I've given the steps. Simplify this and get the answer. So solve it. Solve this as homework. This as homework. Okay. Solve this as homework. Very simple question. Try this on your own. Find the value of dy by dx. To differentiate both LHS and RHS with respect to x. With respect to x. Moving on to the next problem. 7th one. X equals to cos of xy. Cos of xy. Find the dy by dx. Alright. Let's do it. Cos of xy. Please check. Yes, question is right. So what I'm going to do, differentiate on both sides with respect to x. I'll get it as 1. This x differentiation with respect to x is, differentiation of x with respect to x is 1 only. What about this? Minus sine xy. Minus sine xy. What next will come? What next will come, sir? I have to do the product rule for x and y. So I'm going to keep x as it is, and for y I'll get what? Dy by dx plus, for I'll keep y as it is, and for x I'll get what? 1. So I'm using the differentiation rule. Sorry, product rule for differentiation. for xy. So I kept x as it is, differentiation of y is dy by dx, okay, and then I kept y as it is and differentiation of x is simply 1. Now please simplify this. 1 goes to minus sine xy, what is it? Y plus x dy by dx, x dy by dx. Do one thing, open the bracket over here. What I'm gonna get? Minus sine xy times what? Times y plus minus sine xy x dy by dx. I want to find dy by dx, so all the other terms I'll keep over this side. So I'll get over here 1 plus sine xy times y, right? So I'm going to write it like this. This is y. Just simply like this. I'll write it as 1 plus y sine xy. So I've brought this over here. This whole term on this side of the equal to sign. If I do that, I get plus sign, okay? What is left over on the right hand side? Minus sine xy with x dy by dx, dy by dx. I want to keep dy by dx only on that side. So what I'm going to get? 1 plus y sine xy upon, this whole thing will come here. So minus sine xy multiplied with x. What I'm going to get here? Dy by dx. So I can simply rewrite this as dy by dx. Dy by dx is equals to what, bacha? This minus sign will go up. So minus 1 plus y sine xy, y sine xy upon what? X sine xy. Please check. Minus 1 plus y sine xy upon x sine xy. Option A is correct answer. Minus sign 1 plus y x sine xy, x sine xy. Please check. X sine xy, 1 plus y sine xy. Simple question. Very simple question. Okay. Alright. What about this, sir? X times of 1 plus 1, x times of root of 1 plus y times of root of 1 plus x equals to 0. Find dy by dx. Find dy by dx. Alright. How can we get it? Can we simplify this? Let's do one thing. It's already given as 0. I'll take the root on the other side and then square it up. Okay, makes sense to us. Then I won't have to deal with roots. Let's check. So I can rewrite this as x times of 1 plus y equals to minus y times of root of 1 plus x. Now square both sides. Square both sides, please. How will this look like? X square 1 plus y equals to y square 1 plus x. Yes or no, sir? Yes or no? X square 1 plus y square 1 plus x. Correct? Please check here. How will this look like? X square plus x square y, correct, equals to y square plus y square x. Correct? Move these things over here. What I'm going to get? X square plus x square y minus y square minus y square x equals to 0. Correct? Correct or not? I move these two terms on the left hand side. So y square and y square x will come on this side. How will that look like? Please look in the next slide. So I have x square y minus y square x equals to 0. Same step I've written here. Okay. Now I can club these two together and these two together for the factorization part. So what I'm going to get? X square minus y square equals plus x square y minus y square x equals to 0. Please check it. This is my steps. I'll take this simple formula a minus b and a plus b. So x minus y times of x plus y, and this will be what? What is common over here? I can see xy is common, right? X square y square x. So xy is only common. What is left here? Only x is left because y already have taken common. Over here what? Minus y is left equal to 0. Please check here. Common, common. I get x minus y common here. What is left now? X plus y plus xy equal to 0. Correct? X plus y is left over here. Xy is left over here. So x plus y plus xy equal to 0. So basically from here if you see, I have two conditions. One is y equal to x, other is x plus y plus xy equal to 0. Correct? So from here if you put this as equal to 0, you'll get y equal to x. Other one, x plus y plus xy equal to 0. Let's differentiate this part. For over here what are you gonna get? Simply 1. Please check. Over here you're gonna get what? Simply 1. None of the answers is like this. So we are looking to find what? Derivative of that part. Okay, y equal to x if you want to take. Okay, yes, yeah. So if I take the derivative of this part, I'm going to become what? So let's simplify this. What I'm going to get? I'll get x plus y times of 1 plus x equals to 0. Correct? What I'm going to get now? Y times of 1 plus x will be equal to minus x upon, not upon, we'll come to the next step later. Please check here, please check here. Minus x. Why minus x? Because I'm bringing this x on this side. Okay, now what next? Now I'll keep writing this as y equal to minus x upon 1 plus x. Y equal to minus x upon 1 plus x. Let's do the differentiation of this. What is the function now? What that we have? Minus x upon 1 plus x. Minus x upon 1 plus x. Okay, alright. Let's do the derivative. We'll get what? Dy by dx. Alright, just give me one more second, sir. Okay. So I'll write it as dy by dx. I have to use what bacha here? I have to use quotient rule. So I'll write for first minus x. If I do the differentiation, what I'm going to get? I'm going to get it as, I'll keep 1 plus x as it is. I'll do this for, I'll get minus 1 minus times of what now? I'll keep this minus x as it is. I'll do for this 1 plus x, I'll get what? Simply 1. Please check. Differentiation of 1 is 0, x is 1. So simply 1. Okay. What is the denominator? 1 plus x the whole square, sir. What I get now over here? Minus 1 minus x plus x upon 1 plus x the whole square. This and this goes out. What is the answer? Minus 1 upon 1 plus x the whole square. Any option like this? Please check. Please check. Minus 1 upon 1 plus x the whole square. Option C. Minus 1 upon 1 plus x the whole square. I hope this is clear. Yes. Yes. Let's move on to the next problem. Let's move on to the next problem. Over here, if y equal to root of a square plus x square is given. Okay. Looks complicated right now. Looks very complicated right now. Let's do one thing. Let's just simply do one thing. What are we going to do? To simplify our work, we'll assume a substitution over here for this. For t equals to a square plus x square. For t equals to, so I'm taking this root, this whole root as t. Okay. So what this question will become for us? Y equals to root of a square plus t. Yes, bacha? Yes, sir. Let's simply square on both sides. I'll get what? Y square equals to a square plus t. Yes, sir. Let's do one thing. Let's do the what do you call? Derivative on both sides with respect to x. Derivative on both sides with respect to x. Why, sir? Then only I'll try to get this part. Then only I'll arrive this part. No, dy by dx from the left hand side. Please check. If I do that, I get 2y dy by dx. That's what we need, right? We need the value of dy by dx. What is this going to be? 0, sir. 0, sir. Okay. What about this? What about this? This is nothing but differentiation of what? Root of a square plus x square. Because what is my t value? Root of x, a square plus x square. Yes, sir. How will this look like? Please check. This will be 0 is because a square is a constant, so 0. Okay. What about this? It will be simply 1 by 2. Why, sir? What is the power? Root means power is what? 1 by 2. And this will be what? A square plus x square. Correct? Power 1 by 2 minus 1. N minus 1. N was what? 1 by 2. N minus 1. But is it enough? No, sir. I have to do for x square again. So what I'm going to get? 2. I'm going to get what? 2x. Please look at here. This is my chain rule. First I did for this part. In which form? 1 by 2. This is written like this. A square plus x square power 1 by 2. So 1 by 2 came in front. 1 by 2 minus 1 and minus 1. Then again I have to do for the denominator part, the inside, this part. For a square I'll get 0. For x square I'll get what? 2x. Okay. Hope this is clear. Hope this is clear, sir. Yes. Yes. Okay. Let's see this next step. Let's see this next step. What I'm going to get? 1 by 2. I'll get a square plus x square power minus 1 by 2. And this will be simply 2x. I cancel this 2 and 2. Correct? Now what is left over here? Please check. So I have left this thing as I have over here. Okay, I can write in the next slide. Let me write it over here. So far I've got this 2 dy by dx. 2 dy by dx equals to what? Minus, please check. There's no minus here. There's no minus here. So a square plus x, a square plus x square. This is not x, bacha. a square plus x square power minus 1 by 2, a square plus x square power minus 1 by 2 times of what? X. Now please cross check. 2 and 2 is cancelled, so only x is left. Okay. Now power minus 1 by 2 means what? I can take it to denominator. 1 by 2 means what? Negative means 1. I can take it in denominator. 1 by 2 means root. So I can simply write this as 2y dy by dx is equal to what? 1 upon a square plus x square in the root in the denominator. Negative sign makes the denominator part. 1 by 2 makes the root part. Okay. What is left in the numerator? 1 into x. So I can write dy by dx as what, bacha? Please check. X upon 2y root of a square plus x square. A square plus x square. What's my y value? What's my y value? Please check. This whole thing. So I can rewrite this as x upon 2 times of a square plus x square, and this thing multiplied with what? This another a square plus x square. This is only for y. This part is only for y. Okay. I hope this is clear. Please have a look. Question was given like this. We had to find dy by dx. We took the substitution for root of a square plus x square as t to make first step simpler. From there I got this differentiation for using chain rule, applied and simplified this as this, and then rewrote the value of y from the given expression. Simple sir. I think yes. The last problem of the day, very last problem of the day, very simple. You'll use two formulas here. Okay, what is it? 1 minus cos x. Remember, this is nothing but 2 sine square x by 2, sir. Please understand this. Correct from here. And what about 1 plus cos x? Same way, sir. 2 cos square x by 2, sir. How, sir? Forgot this formula? Sine, not sine, cos 2 theta. Please remember this. So cos 2 theta is nothing but 2 cos square theta minus 1, also nothing but 1 minus 2 sine square theta. If you replace 2 theta by x, if you replace this 2 theta by x, you will get the same answers, this one and this one. If you use two branches, cos 2 theta with sine square theta, replace 2 theta by x, you will get the same answer. If you replace this 2 theta by x and use the second branch, 2 cos square theta minus 1, you'll get the second part. Okay. Now I'm going to use these expressions over here. Why I'm using this? If you say check here, I'm getting squares in both the steps. Getting squares over here also. Square and square will make something, make the root go out. So how will this look like? My function y will become root of 2 sine square x by 2 upon 2 cos square x by 2. 2 and 2 goes out. What I'm gonna get? Tan square x by 2. Now root and root will cancel each other. Root and square will cancel each other. So root and square root, yeah, correct. This will become what? Simply tan x by 2. This is my y. I want to find the value of what? dy by dx. Value of dy by dx. What I'm gonna get? Please check. dy by dx will be simply sec square x by 2. Tan differentiation is sec square, and then we have to do the chain rule for the x by 2. Simply will be 1 by 2. Correct, na? Because for x will be 1 and 2 is a constant, so 1 by 2. But I'm going to get 1 by 2 sec square x by 2. Any option like this? Please check any option like this. Yes, sir. Option A. Option A is my correct answer. Okay. So this was it, bacha, for the basic differentiations, right? So we tried to learn today what is differentiability. When can I say a function is differentiable? Okay, then we talked about intervals, right? We talked about in open interval, how will it work? When can I call the function to be differentiable? We talked about closed interval also. Then we went ahead to make a relation between continuous function and differentiable function. What was the relation? If a function is differentiable means it will be continuous, but if the function is not continuous means it can never be differentiable. Okay, what about other case? A function is continuous means it can be differentiable, it may not be differentiable. Okay, so the condition will be like that. Okay, so next, what was next? then we learned some rules of the differentiation, okay, and then we solved questions on them. So I hope this was helpful. Okay, if you need more questions to be solved in this particular topic, I can add some more questions in this smaller category at the end of the session. Okay, so make sure that you have this understanding of this, and if you need me to solve more questions, comment below. I will come up with more questions in the same concepts, in the same topics, and we will deliver it in the next session. I hope this is okay. So for today, let's say goodbye. Make sure that you're working really hard, okay, and take care. All right, say bye bye.